Okay, problem number 2. Again, we're going to get a generating fraction, and then we're going to try to find the nth term of that generating fraction. So we're given this series, and we'll write it down at the whiteboard, and then we'll go through the method. By the way, I want to pay careful attention to footnote, and it's helpful, by the way. It says second order, so that's going to help me do the problem, all right? So let's go to the whiteboard and write it down. So what do you get? I'm going to write this down as S equals, make sure my pen is out, yep. S is equal, and what does it equal? It's equal to 1 minus 13x minus 23 x squared minus 85x cubed minus 239 x4 plus yada, yada, yada. All right? The first thing I do is, I'm going to multiply s by ax. Let me write this down. And then what are you going to get? I'm going to try to line things up for you. You're going to get ax minus 13 ax squared, excuse me, minus 23 ax cubed minus 85 ax4, and I'm just going to say yada, yada, yada at this point. All right, let's put the next one down. The next one's going to be bx squared now. All right, let's do this one at a time. So it's going to be bx squared. All right, let's keep going. The next term is going to be minus 13 bx3. And next term is going to be minus 23 bx4 plus yada, yada, yada. All right? So you're going to add these things together with the hope that things are going to start to disappear, but they're only going to disappear if you can figure out what the a and b is to make them disappear. So let me write this down. If I add this together, this would be s I'm sorry, not equals. That's would be going too far, wouldn't it? Backwards a little bit. 1 plus ax. I still don't know what a is. Plus bx squared equals, well, I want this to equal, I want this thing to disappear, I want this to disappear, and I want this to disappear, so forth and so on forever. Right, so really what I'm looking for over here is hopefully I'll get something that looks like this over here. 1 minus 13x plus ax. Let me get my eraser out again. I don't know what a is, I don't know what b is. But what I got to do now is I got to concentrate on getting that square to disappear. So I'll write this down. So I want the coefficients to sum to 0. So I want minus 23 minus 13a plus b to sum to 0. And I want that next guy, the cubic term, also to disappear. And what do you get there? Let's take a look at that. You can get minus 85 minus 23a minus 13b is equal to 0. All right, let's take a look. And I guess I got to figure out, there's two equations or two unknowns. And I got to figure out how am I going to do that. Well, I'm going to multiply the top equation by 13. Please feel free to use a calculator. All right. I'm going to write this on the side, though, as I do it. And, 13 times 23. Well, it's 230. 10 times 23. And then 3 times 23 is going to be 69. So that would be 299. And then you're going to get what? Minus 169a plus 13b equals 0. Let me get my eraser out. I'm going to erase this business over here. These are difficult problems. I'm not saying otherwise. And let me keep going. I'll write this down. Minus 85 minus 23a minus 13b equals 0. All right, the point of that was I'm using the technique of addition or Gaussian elimination, and I'm going to add it together. And you would get 0. The b's would disappear, which is what I wanted. And then what do you get? Let's write this down. You're going to get minus, let's see, that would be 72, 82, 92. And then you're going to get minus 384. All right? So I got to figure out the a now, right? So looking at this, I'm going to say minus 384 is equal to 192a, and a would equal minus 2. Let me just check that. 180, yeah, looks pretty good. All right, so I know what the a is. Now, the problem, do I really need to figure out the b in the problem? And I do, because I need to know this, and I need to know this. All right, so let's put this down. I need to pick one of these equations to do it. And I'm going to pick, I don't know, I think I'll pick this one. So what do you get? You get minus 23. Well, that's going to be plus 26 now because a is minus 2, right? Plus b is equal to 0. So you would get 3 plus b is equal to 0. So now I know b is minus 3. All right? All right, let's write this down now. And I'm going to say S is now equal to, I want to point out I'm doing this now, and that's going to be 1 minus 13x minus 2x, which is 1 minus 15x. All right, I'm going to divide by this now, because I want to find out what S is, and this is the fraction I'm looking for, and that's going to be 1 minus 2x, because a is minus 2, and b is minus 3, so minus 3x squared. Now, as we did for problem number 1, I did a long division to check it. I'm not going to do the long division now, all right? What I'm going to do is I'm going to use partial fractions to break this thing up. And yes, I noticed a lot of work. So let's take a look. This is equal 1 minus 15x, and it's going to be 1 plus x. I'll check this when I write this down, by the way, and 1 minus 3x. And what do you get there? Well, you do get 1, and you get minus 3x plus x, which is minus 2x, and you do get minus 3x squared. So I'm going to write my partial fraction decomposition down now. I'm going to say a over, I just don't know what a is. By the way, these are different a's now. I'm not saying it's the same a we had before. All right, I'm just using this thing over here. I'm done with the prior a, by the way. And b, which is not the prior b. I'm not saying it is. What do you get over here? Clear the fraction. And what do you get there? A, 1 minus 3x, plus b, 1 plus x. I want to pick an easy x. I'll pick x to be minus 1. And you would get 16 equals 4a, which means a is 4. Now, if I want to get the b, I'll set x equal to 0. I would get 1. Well, let's see. What would I get if x is 0? And again, we got to be careful because I don't want to make a mistake. Let's see. A is 4. X is 0, so it's going to be 4. I don't know what b is. And if x is 0, I just get a multiplier of 1. So b would have to be minus 3. All right, let's write this down now. And 1 minus 15x, this is what s is, by the way, just a fraction. It's not true for all numbers, but it's true for some numbers. And I'm going to write this over here. We'll talk about what's called the interval of convergence for this. And the a is 4, right? So 4 over 1 plus x plus, not plus, it's going to be minus, right? The b is 3 over 1 minus 3x. All right? I want to get the general term, and I have to recognize these are geometric. All right, so let's write this down. And this is going to be 4. I'm doing this term now. It's going to be 1 minus x plus x squared minus x cubed plus yada, yada, yada. All right, I'm just getting a general pattern down. Then I get minus 3, 1 plus 3x plus 3x squared plus 3x cubed plus yada, yada, yada. All right, I'm going to try to pull it together. And let's write this down. And I'll just, kind of pairwise get it. So it would be 4 minus 3. And then you're going to get plus, well, let's see, I'm going to do the x now, right? I want to point out what we're doing over here. And let's see what you're going to get there. You're going to get minus 4. Minus 3 times 3. Let's go to the next term. You're going to get an x squared term now, right? And what do you get there? You're going to get 4. And then you're going to get minus 3 times 3 squared. And the reason for doing this is so you can see a pattern. Now, some people see patterns quicker than others. And don't be discouraged. I'm just going to bring it out to this. And then we'll talk about what I'm seeing. All right, so what do you get over here? Well, you're going to get minus 4. And then what do you get? Let's take a look. We're looking at the cube term, right? This going over here. You're going to get minus 3 times 3 cubed. All right? It goes on forever. So let me just kind of maybe change that first term a little bit. Get my eraser out. I want to make it look like the other terms. Minus 3, 3 to the 0, and there's no x there. So I can say it looks like the other terms. Now, I know that Wells likes to start at 1, and that's nothing wrong with that. But I'm going to start at 0. And I'm going to say j equals 0 to infinity. And let's start writing this down. So it looks like I got like an alternating pattern on the 4. So I'm going to put minus 1, 4. And the 4 is not changing, but the sign changes, right? I made a mistake somewhere. I just noticed it. And I'm sorry, I made a mistake. I got to correct it. If someone said, make a mistake, you look at it, you made a mistake. I erased it. So minus 4, 4, 4, minus 4. I think I still made a mistake, didn't I? I got to check it again. Let's get the right pattern, right? So it's 4, then minus 4, plus 4, minus 4. Let me see if I got that right now. 4, minus 4, 4, minus 4. Yeah, I apologize. Made a mistake there. All right? So I'm going to say it alternates, and I'm going to say there's a j here. J to the 0 would give me that 4 there. Then I get minus 4, 4, minus 4. All right, let's go to the next guy. What do I see? I minus 3. And then I see 3 to the j. And again, I'm seeing this. I'm seeing it. I'm seeing it. I'm seeing it. And then what I get x to the j. All right, and this is starting at 0. So I could write this down now. an is equal to minus 1 to the n, 4, minus 3, 3 to the n, x to the n. And this is if we start at n equals 0. So n 0, yada, 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 yada. All right? Now, I realize Wells like to start at 1, so let me do that then. This is a different one. I'm going to start at 1 now. So minus 1, n minus 1 times 4, minus 3 times 3, n minus 1, x to the n minus 1. And this starts at 1. Yada, 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 yada. So someone's going to say, you know, what happens if someone wants to simplify that a little bit further? And you could, right? So one thing I want to do is, let's see. I think I can simplify a little bit further. I'm going to work on this one over here and simplify a little bit further. an minus 1, n minus 1, 4. And I'm going to write this as just 1 power of 3. What would that be? Minus 3, n minus 1 plus 1 is just n, right? And then you get x, n minus 1. And again, we're starting at 1. And Wells likes to start at 1, so we'll start at 1. Put a box in this. And I want to do one other thing, which is the interval of convergence in this over here. And I want to point out what we're using is the geometric. And the geometric we're looking at is this one over here, 1, 1 minus u. And this is 1 plus u. We just used that, by the way, u squared, yada, yada, yada. And this converges for these values over here. So I got to go back to my original series and realize, you know, the first one here, this would converge for the absolute value of x there. And the other one would be the absolute value of, let's see, 3x would be less than 1. This is more restrictive. So I'm going to say this converges for the more the restrictive one. So it would be the absolute value of 3x less than 1. And what does this mean? X is between 1/3 and minus 1/3. All right? That's the interval of convergence for that. So let's take a look at the answer key. And hopefully I didn't make a mistake. I always say sometimes I make a mistake in counting. And let's take a look. Get my red pen out and see if we have the answer. And again, Wells likes to start at 1. That's what I'm doing over here. And I see this. I see the minus 1 to the n minus 1 times 4. I see this, and I see this, and I see that interval written down as well. This over here. Now, the way they wrote it down this way over here. The absolute value of x is less than 1/3. That's the same thing as written over here. So things are fine. Thank you.